Sir, Krishna Reddy sir.
Yes, ma'am.
Sir, this is the last topic from CO3, no sir?
Yes, sir, ma'am.
Okay.
Yeah?
లేదు 28 29 ముందు సెషన్లకి మనం 2 తగ్గాయి 29 లాస్ట్ సెషన్.
అవును.
అదే ట్రావెలింగ్ సేల్స్ పర్సన్ ఫార్మ్ ఇవాళ కాక ఇంకొక క్లాస్ అయితే అయిపోతుంది సార్ ఇది CO3.
ఎందుకు మేడం ఈ రోజు అయిపోతుందిగా?
అంటే మనం ఇంకో సెషన్ లో ఎగ్జాంపులే ఉంది మీరు పెట్టిన స్లైడ్ లో 29 స్లైడ్ ఉంది కూడా ఉంది కదా సార్?
ఉంది మేడం 29 స్లైడ్ కూడా చెప్తారు ఇవాళ.
అవునా? రైట్ అయితే అయిపోయింది ఇంకా CO3. గుడ్ సార్.
I will take care, ma'am.
Right, sir. Right.
Okay. Good afternoon, all of you. I hope you are comfortable with branch and bound with the previous example. Zero knapsack problem by using 3 methods. First, we already completed FIFO-BB zero knapsack problem. Next, we discussed about LCBB and followed by LIFO-BB also. Out of these 3 methods, these 2 methods are blind methods. That's why the state space tree, the scope for getting the answer node in a state space tree is huge compared to the LCBB. Then you can solve same zero knapsack problem with the same example by using 3 methods. Then you can identify which is efficient one, why you are going for LCBB compared to the FIFO-BB and LIFO-BB. Okay. So that concept is over in the previous class. You need to practice those 3 methods for generating those nodes by just seeing for getting the values of C cap value and U value, lower bound, upper bound, and bounding function verification. So it's very easy by just seeing on the slides and calculation by someone else is completed. Okay, but you have to practice it from starting to ending. Then you have huge doubts will be there, why you are taking node 6, why you are killing the node 5, like the type of doubts will be raised. Those doubts will be clarified in the next session when we are having a free slot after completion of the syllabus or CO4. Okay, I will take those session by announcing in advance. Okay, if anyone have any doubt, then I will clarify those doubts also, why you are killing that node or why you are taking the choice of a particular node to solve from that step. But for those all the things, your practice is more important. Then only it's possible to get the confidence for implementation of branch and bound by using those 2 techniques. Okay, if those 2 techniques or 3 techniques are available in the syllabus or not, please forget about it. In the syllabus, only 2 techniques are there, FIFO-BB and LCBB. But as per concept is concerned, please practice those 3 techniques and identify what is the difference between those 3 techniques. Okay, I will give the solution for those 3 techniques, how nodes will be generated as per discussion of the previous session. I will place that PPT in LMS and the name of the session 24 or 23 or something up to 27. Okay, I will update those PPTs which are there in the LMS with these latest updates of the problem solutions also. But you need to practice for all those 3 methods, okay, and compare with the existing solution. If we have any doubt, then we will discuss in the later sessions when the sessions are free, like I said previous week. Okay, there is no problem for the syllabus coverage. Today we completed the traveling salesperson problem. Remaining only 8 sessions are there. Okay, to complete the entire thing. That's why a huge number of sessions will be free for taking the revision or doubts clarification. Then before that, please practice yourself and come to the exact points or why it's happened in the particular stage. Okay, I'm ready to explain all the backtracking and branch and bound in the later sessions. So please listen and take the rough note, running notes and pen for practicing this traveling salesperson problem also. This problem is very simple, but we need to do calculation for getting the result. Okay, that calculation as per the procedure we have to follow. that procedure you have to practice with numbers. That's why please practice and write the procedure for that practice. Okay, first I would like to explain how we have to apply branch and bound technique for traveling salesperson problem. Before going to the execution of traveling salesperson problem or applying branch and bound, what is the meaning of traveling salesperson problem? Okay, what is the meaning of traveling salesperson problem? After that, we will discuss about how algorithm will be applicable and how to solve the traveling salesperson problem in the branch and bound. Okay, what is the meaning of traveling salesperson problem? Anyone of you? What is the meaning of that? If any example is given, okay, how to identify the solution for traveling salesperson problem, or what is the requirement of the traveling salesperson problem? Anyone of you? The name it can be used traveling salesperson problem. What is meant by salesperson? What is meant by salesperson? What is the duty of salesperson? What is the responsibility of sales executive in our regular business scenario? What is the importance or what is the role of sales executive in day-to-day activities? Okay, please observe. I will give one example to you. In a city, huge number of locations are there, or areas are there. Okay, in the particular city, the sales executive job is okay to visit every day. He will report to the head office. Okay, please assume it is a head office. Every day morning, he will report to the head, and from that location, okay, there is a number of possibilities to reach all the remaining areas of the city. Okay, by using different possible paths, it can be reached the city, all the locations of the city, and distance is also represented in the notation of the city. Suppose it is 10, okay, it is 5, it is 6, it is 8, it is 9, it is 2, it is 3, it is 11, like this. What is the meaning of this edge is, this edge is representing the cost to reach from 1 to 2. Next, this edge is represent that there is a connection directly, there is a possibility to move from location 2 to location 5 with cost of 5. Next, location 2 to location 3, the cost of 6. The cost of the edge is how much cost it takes to travel from source to some other point, that is 2 to 3 or 3 to 4 or 1 to 4 or something. It is a directed edge or in the bidirectional edge. Okay, it's both concepts. The meaning of the edge is the cost from one point to other point can be represented. But what is the meaning of sales executive responsibility? Sales executive every day, the general scenario is first he will report to the head in a particular point, and he starts the journey to marketing those products in different locations of the particular city. So these are the 5 locations. Please observe. First location is the head location or reporting location. The responsibility of the particular sales executive, he will start from one point, and at the end of the day he will reach the same point. Means source and destination both are same. Okay, in the traveling salesperson, responsibility is starts with the same point, and after visiting all the remaining locations of the particular city or the particular region, okay, again he will report in the evening, and he will submit the report or status of the what is the product sale or product booking or whatever it may be. So what you want to identify in the traveling salesperson problem is we want to provide the solution to the salesperson based on the availability of the connectivity of those areas. Okay, you need to provide, okay, what is the best path, what is the best path or optimal path, what is the best path or optimal path to visit all the remaining n-1 locations. Totally here in this graph, please observe 5 locations are there. First location is the starting and ending. There is no need to visit again for that location. What are the remaining locations are there? n-1 locations. What are those locations? Those locations are 2, 3, 4, 5. So remaining 4 locations they have to visit for as a part of their job, but what is the way they have to select? Okay, from 1 to remaining 4 cities, what is the sequence they have to select? There is a number of possibilities are there. Some people may say you can take it 1 to 2, okay, 2 to 3, 3 to 4, 4 to 5, 5 to 1. Some other people may say please take 1 to 3, 3 to 4, 4 to 2, 2 to 5, 5 to again 1. Some other people may say starts with 4, followed by 2, followed by 5, followed by 3, 3 to 1. Like this, number of possibilities are there, permutations are there to visit remaining 4 cities. Okay, there is a possibility of 5. Okay, but which path it gives the minimum cost? Which path it gives the minimum cost? Here, there is huge number of feasible solutions are there. We want to identify optimal solution for traveling all the remaining n-1 cities. Starts with some source, and the destination is also fixed in this path or in this traveling tour of the salesperson. In the tour, source and destination is always fixed. There is a starting point, and remaining n-1 only we have to focus. That n-1 order, number of possibilities are there based on the connectivity of those areas. Based on those all the possibilities, which possibility or which path it gives the optimal cost? Which possibility cost minimum cost or optimal cost? That path we have to specify at the end of the solution. The problem is traveling salesperson problem. But suppose the person is new to the particular city. Okay, so they are giving the target in the particular city. So these number of areas are there. The locations of the shops or retail shops or wholesale shops or shopping malls or whatever it may be. We have to visit all these locations for the visiting the customers to promote our products. Okay, they will give the list of points, but where he will start and what is the next point and what is the next point to identify the optimal cost to visit all the n-1 points. Again, you have to report to the same location of the starting value. Okay, that is the problem. Means huge number of possibilities. Suppose they are taking the long path, it takes a lot of time. It is a waste of the time of the salesperson to visit all the locations. That's why the minimum cost we have to suggest. Okay, where you have to start and what is the next node and what is the next node and what is the next node. What is the sequence of nodes you have to visit or locations you have to visit, and finally you have to reach the same location of 1. Okay, that is the main aim. The problem is to identify the minimum cost to travel the salesperson from one vertex, means starting vertex, to the same vertex by using n-1 vertices. And one more condition, in this path repetition of the node is not allowed. In this path repetition of a node is not allowed. So starting source is 1 and destination is also fixed to 1. Remaining only n-1 nodes which are not visited up to now. Those nodes only we have to use. Distinct nodes only we have to use. That is n-1 nodes as per the given information. So repetition is not allowed. Suppose once we are visiting the location 4, that location 4 in the particular path, this repetition is not allowed. So all the remaining only we have to travel. So I hope you got the meaning of what is the traveling salesperson problem. Okay, how we are targeting to get the solution. The target is to identify the shortest path from source to destination by using n-1 vertices. For that purpose, so as per our diagram is concerned, we are taking the diagram 1, 2, 3, 4 like this. Okay, the paths are like this with the cost of 10, 20, 5, 6, 7 are like this. This is a graph representation. Graphical representation is very easy to identify the corrections in between the vertices. But in the traveling salesperson problem, the graph we are converting into matrix representation. That matrix we are calling as a cost matrix. That matrix we are calling as a cost matrix. Cost matrix is nothing but the cost in between the vertices. Suppose the given graph it contains 4. So 1, 2, 3, 4. The size of the matrix is 4 by 4. So n number of vertices are there. The size of the matrix is n by n. The same number of rows and same number of columns will be there. Okay. So next value, if the cost C of ij means ith row and jth column, we are represented if the cost of the particular node to particular node I comma j, there is no edge in between I comma j. If it is the same value C11, it is make as a 0 because from vertex 1 to vertex 1 the cost is 0. and vertex 1 to vertex 2 as per the edge is concerned 1 to 2 is 10. So 1 to 3 the edge is 5. So 1 to 4 the edge is 7. So the row representation indicates from 1 to all the remaining vertices what is the cost as per the given information, the edge value of the particular pair of the vertices. Suppose from 2 to 1 it is 10, it is a bidirectional edge, please assume like that. So 2 to 2 it is 0. Next 2 to 3 is 20. 2 to 4 there is no edge. If there is no edge then please represent with infinity. Okay, if C of I comma j edge is not available, I comma j does not belongs to E, means there is no edge in between 2 to 4. In this graph there is no direct edge from 2 to 4. Those edges we are representing with infinity representation. Okay, so 1 to 1 also we have to assume it is also infinity representation. 2 to 2 also we have to represent, there is no cost, that is we have to represent with the infinity. Next one 3 to 3 infinity, 3 to 4 6, 3 to 5 sorry 3 to 3 2 to 1 10, from 3 to 1 5, 3 to 2 20, 3 to 3 infinity, 3 to 4 6. Similarly from 4 to 1 7, 4 to 2 there is no edge from 4 to 2, that's why infinity, 4 to 3 6, 4 to 4 infinity. So this matrix we are calling as a cost matrix. Okay, every time we will give either in the diagram representation for traveling salesperson problem based on the number of vertices, or the input is in the form of cost matrix also. Cost matrix infinity is nothing but there is no direct edge from vertex to particular vertex. Suppose 2 to 4 there is no edge, that is called infinity. If there is any direct edge, the cost value is represented in the cost matrix. There is a cost matrix representation for okay given input representation is the cost matrix. But before going to the formula or notation representation, we want to learn some more value. Okay. Reduce the cost matrix. This is the cost matrix. So before going to the original concept of the given traveling salesperson problem, we want to learn some basic things of the mathematics which are very much useful for the entire calculation. 70% of the calculation is based on this representation only. That's why first we have to learn that part, then we will go with step-by-step procedure for traveling salesperson problem. Suppose any cost matrix is given, I will give an example. Any cost matrix is given alpha 20 30 10 11, next value 15 infinity 16 4 2 and 3 5 infinity 2 4, next 19 6 18 infinity 3, next 16 4 7 16 infinity. All of you please note down this matrix. Is a 5 by 5 matrix, given cost matrix. See, okay, I want to make this matrix as reduced cost matrix. What is meant by reduced cost matrix or reduced matrix? What is the meaning of reduced matrix? What is the condition for that? If any matrix is a reduced matrix, here conditions are there. Each row contains at least one zero. Each row contains at least one zero. Second one, each column contains at least one zero. Third one, if These above all the conditions except row or column contains infinity, except the above two concepts except the row or column contains all values are infinity. If all values are infinity, there is no need to justify the above 2 points. Okay, row must be reduced, all rows must be individually reduced, and all columns must be individually reduced. Reduce is nothing but out of the particular row it contains at least one zero. Then how to reduce that? So most of them are known this concept, is already there in the mathematics representation. So I want to focus first. You want to reduce this matrix is nothing but 5 rows must be reduced and followed by 5 columns must be reduced. How to reduce it? So 1, 2, 3, 4, 5 row wise, column wise 1, 2, 3, 4, 5. 5 columns are there and 5 rows are there. 1, 2, 3, 4, 5. So first I want to reduce rows. Rows reducing. All of you please focus. Please respond. How to reduce this row? First row is out of this first row. What is the minimum value is there? How many values are there? Totally 5 values are there. Out of 5 values, what is the minimum value out of those 5 values? Infinity, 20, 30, 10, 11. What is the minimum value? 10. Please subtract this minimum value from the given set of row values. So infinity minus 10, infinity, 20 minus 10, 10, 30 minus 10, 20, 10 minus 10, 0, 11 minus 10, 1. So reduced cost, first you are applying 10 on first row. So we are reducing that 10 from all the elements of the first row, then automatically first row is in reduced. Each row contains at least one zero. First row is contains at least one zero with non-negative values. Second row, so we want to reduce. If it already contains any zero in the particular row, there is no need to reduce. If there is no zero, then we have to apply reduce function on that. So please observe 15, infinity, 16, 4, 2. There is no zero, that's why we need to apply the minimum value out of this 5. Then we have to subtract that value from the second row. So what is the result? 13, infinity, 14, 2, 0. Next, third row. Please observe any row 0 is there in the particular row? No. Then we have to reduce minimum value out of all the values of the particular row. Then 1, 3, infinity, 0, 2. From fourth row, there is no 0 in the particular row, that's why it is not reduced as of now. Then take the minimum value 3, then 16, 3, 15, infinity, 0. Next, fifth row, there is no 0, minimum value is 4, means 12, 0, 3, 12, infinity. Okay, so 2 plus 3 plus 4. So row wise reducing, the reducing cost we are applying first row 10, second row 2, third row 2, fourth row 3 and fifth row 4. Okay, then automatically all rows, please observe, row wise reducing is over. Then we have to focus on column wise reducing. So all of you please observe, if it is already reduced, there is no need to convert. Then how we have to apply? The first column, please observe, in the first column, is it contains at least one zero? No. Then what is the minimum value? Minimum value is 1. So please subtract with that in the column wise 12, 0, 15, 11. Okay, column cost is 1. Second column is already reduced because the fifth value in the second column is 0. So 1 0 is there, the column is reduced, already in the reduced mode. Next, third column is not reduced mode, means at least 1 0 is not there. Then take the minimum value 3, then subtract all the values with minimum value. So second column as it is we have to write because it is already reduced mode. Third column, please subtract 3, that is 17, 11, infinity, 12, 0. So the cost is added here. Next, fourth column, contains 2 zeros, then automatically it is already reduced. So there is no need to apply any subtraction here because it is already in reduced mode. Next, fifth column is already contains 2 zeros. 1 zero is more than enough to declare the particular column is in reduced mode. So only 2 columns were updated. 3 columns are automatically updated due to the row reducing. So the total cost for reducing this matrix, from input we are taking this as a given matrix, apply the rows reducing and column reducing, finally we got this matrix is a reduced matrix for the given input matrix. So reduced cost is 10 plus 2 plus 2, 14, 17, 21, 21 plus 4, 25. So the cost for reduced matrix is 25. This process is very important. Okay, for applying this calculation of traveling salesperson problem in the branch and bound. If you are comfortable with this, how to reduce the cost matrix or how to reduce the given matrix with some cost value. Okay, by using these 2 points, each and every row and column must be reduced. It contains at least 1 zero. Okay, except all the values of the particular row or column contains infinity, you have to apply the above 2 conditions. Okay, if you are comfortable with this calculation, then automatically you are comfortable for doing the remaining. So are you comfortable with this calculation? Traveling salesperson problem, reduced cost matrix representation. Say yes or no in the chat box, then we'll continue with the original procedure for cost traveling salesperson problem. So please come to the original concept of traveling salesperson problem, how it can be defined. So major part, 80% of the part is reduced cost matrix only. So if you are comfortable, then it is very easy to identify the solution. All of you please observe. We need to discuss the original concept of traveling salesperson problem. Some graph is given. There is a directed weighted graph. Weighted graph is nothing but cost values are given on edges. It is very important. And directed graph and weights are given. There is a cost from one vertex to other vertex, and define the instance of traveling salesperson problem. There is an input for traveling salesperson problem. In that graph, from one vertex to other vertex, see ij. So I comma j are 2 vertices, and there is an edge in between ij from vertex I to vertex j, any edge is there, Cij is nothing but the cost in for the edge ij. Okay, there is a positive weight number. Okay, if there is no edge, then it is always represented as a infinity. Okay, self loop also we are representing as a infinity. From 1 to 1 we are representing as a infinity, or there is no edge from I to j in the given graph, there is also infinity. Infinity is nothing but there is no edge from vertex 1 to vertex I to vertex j. If any edge is there, there is always a positive number. Next one, what is our aim? Suppose n is equal to 10 is given, means in the given graph number of vertices are 10. What is our aim? Our aim is to identify the best path from starting vertex 1, default value we are taking as a 1 out of n values, and ending vertex is also 1. In between n minus 1 edges we are representing with all the possible permutations. What is the best we have to represent with n minus 1 edges. N minus 1 as per n is equal to 10. 9 values we are representing here. Okay, 2, 3, 4, 5, 6, 7, 8, 9. Okay, these values, total 9 values we are giving the representation here. That is in between 1 to 10, 2, 3, 4, 5, 6, 7, 8, 9, 10. These values, this representation we are calling as a 5. So in this way, what is the solution vector we are representing here? 1, 5, 1. 5 is nothing but permutation of n minus 1 vertices. N minus 1 vertices. Okay, there is a representation of the meaning in the general notation. What is the meaning of this general notation? Traveling salesperson problem. Tour starts and reaches the starting and ending value is 1, 1, 5, 1. 5 is nothing but permutations of n minus 1. N minus 1 is nothing but 2 to n. Okay, n minus 1 vertices. Which permutation gives the minimum cost? That's you have to give as a order. So in order to use LC branch and bound, you know the procedure. What is the meaning of LC branch and bound? Least cost branch and bound technique. We already applied in the previous zero knapsack problem. For each and every step, we are calculating the cost function. Out of all the live nodes, which node it contains the least cost, that node we have to select as a E node. There is a purpose of LCBB, least cost branch and bound. Okay, what is the meaning of least cost branch and bound? Out of the set of live nodes as per the current status of the solution, which node we have to select the expansion to the next, there is nothing but E node. That node we are selecting based on least cost function value. Okay, that is called least cost branch and bound. So any cost we are calculating, here two possibilities are there. Particular node is a leaf node or particular node is a not leaf node. If it is a leaf node, please define the path from root node to particular node, means 5 value is finalized, means the permutation is the answer node. If it is a leaf node, please identify the tour defined by the path from root node to the particular node, that is called as answer node. Suppose it is not a leaf node, means it is an intermediate node, then the cost of minimum cost leaf in the subtree A that can be expanded. The cost of minimum cost leaf in a subtree A, that you have to expand. That is called next step we have to move based on that. This is the basic thing or terminology we are using in traveling salesperson problem to identify the result. Okay, what is the state space tree for the representation of traveling salesperson problem? Suppose n is equal to 5 as per our previous discussion. If n is equal to 5, first we have to start with 1. What is our aim? Our aim is starts with 1, ends with 1 by using the possibility of 2, 3, 4, 5, or by using the possibility of 2, 3, 4, 5. Remaining cities are, total cities are 1, 2, 3, 4, 5, because n is equal to 5, 5 number of cities are there, and source and destination both are same 1, and remaining 4 we have to arrange in a particular order. Which order it gives the optimal solution, that's we need to identify. So starts with 1. What is the scope for expansion from 1? Okay, starts with 1. What is the scope for expansion? Expansion is either 2 we have to visit from 1, either 3 we have to visit, or 4 we have to visit, and 5 we have to visit. Means 4 possibilities are there. 2, 3, 4, 5. From 1, default value is 1. So from 1 to 2, 1 to 3, 1 to 4, 1 to 5, this is the scope of the expansion. Next, suppose we are visited 2. What is the scope from there? Suppose we are visited 2. Okay, what is the scope? I will explain like this. 1, 2. For first one, scope is either 2 from 2 2, 3, 4, 5. Suppose from 1 to 2 is already visited. From next node, what is the scope from 2? From 2 there is a scope, 2 is already visited, either 3, 4, 5. Suppose 3 is already visited, there is a scope for 2, 4, 5. 4 is already visited from 1, the scope is either 2, 3, 5. 5 is already visited, there is a scope from 2, 3, 4, because 5 is already visited now. The remaining part is like this. Like this, from 1 to 2 is already visited. 3, 4, 5. Suppose 2 followed by 3 is already visited. The next nodes are only 4 or 5. 4 are already visited. The next node is only 5. 5 is already visited. The next node is only 4. The tour any path it contains without any repetition, we have to visit n minus 1 vertices. So based on the combination, 2 comma 4 is already completed. Then only the possibility is 3 comma 5. 3 is already visited. The only combination is 5. 5 is already visited. 3 is the only combination. Suppose from 5, okay, 2 comma 5 is already visited. Then the scope is only 3 comma 4. So 2, 5, 3 is already visited. The scope is only 4, or the scope is only 3. Like this we have to expand. There is a scope of state space tree. This is for n is equal to 5. If suppose n is equal to 4, this is a state space tree. From 1 there is a possibility of 2, 3, 4. Suppose we are visited from 1 to 2, means 1 to 2 is already visited. The next scope is either 3 or 4, because 2 is already visited. Suppose we are fixing the 3, the next scope is only 4, because the intermediate nodes are only 2, 3, 4 you need to visit as per traveling salesperson. End is already fixed to 1. There is no need to represent explicitly for starting value and ending value. Default values for starting tour and ending tour is fixed to 1. So intermediate nodes only 2, 3, 4 you are presenting. This is the one possibility. Suppose after 2 you are visited 4, the next scope is only for 3. So 2, 4, 3. Suppose we are starting with 3 after 1, then the scope is for 2 or 4, the next level. Okay, suppose you are selected 2, next level is only 4. Suppose you are selected 4, next level is only 2. Suppose you are selected 4, 2 comma 3, or 3 comma 2. This is the next combination. This is the total state space tree when the number of nodes are either 4 or number of nodes are 5. Okay, in this way we have to search the answer nodes based on the LCBB representation or PCOBB representation. All three are acceptable. This is the scope of the problem. Okay, we need to expand. Okay, based on the given input values. Okay, so all of you please note down this entire procedure. This procedure we have to apply for, like as a knapsack problem, you have written some kill node or some node value before starting the problem. Okay, in the same way, we have to represent this is the total procedure for getting the traveling salesperson result. Okay, yeah, all of you please note down this procedure, these 4 points. Each and every step we are applying these 4 points. Okay, that's why for reference you have to note down these all the 4 points in your running notes. All of you please note down it fast. Meanwhile, please already అడగండి all of you please note down I hope you have copied this information. These are the basic functionality we will use for cross-checking the optimal path in traveling salesperson problems. I will explain what is the meaning of this is. If any matrix is given, first we have to reduce that matrix by identify the reduced cost, means all the rows and columns must be reduced. Okay. After that, the row I and row column J we have represents with infinity. Change all the entries of row and column J. Next, A of J comma 1. A is nothing but parent node of the current chain node, thus we have to fix it to infinity. And we have to reduce that except infinity values reduce in cost matrix, and you have to take the cost of a particular child by using the formula cost of the parent plus parent A of I comma j value, and R is nothing but reduced cost. Okay, that is which is there in the step 3. All these process we need to apply for taking some example. So we will continue with example. Okay, so all of you please starts with an example. We need to identify traveling salesperson problem by using given cost matrix traveling salesperson problem for given cost matrix. So all of you please observe what is this cost matrix, how many nodes are there in the given cost matrix is nothing but the size of the matrix, that is 5 by 5. So the number of vertices in the given graph is 5. So what is our aim? Our aim is to identify the shortest path to travel by given salesperson. From 1 to 1 is fixed, but in between 4 remaining n minus 1 are there, that is 2 comma 3 comma 4 comma 5. We have to arrange these vertices to identify the shortest path in between 1 to 1. That's we are calling as a 5. You need to identify the path in between 1 to 1 by arranging these objects. That's we need to calculate that path. So before going to that, again we have to see the procedure where we have to start and where we have to calculate. Okay, everyone is perfect how to reduce the given matrix, reduced cost matrix. We already discussed this reduced cost matrix. For each and every row we have to reduce, means is nothing but each and every row it contains at least 1 0 after reducing. It already contains 0, the matrix is already reduced, otherwise you have to reduce that matrix. Okay, so first you have to start the solution. First you have to start with state space tree. For the solution, state space tree already we discussed in the previous. If 5 nodes are there, how we have to identify the state space tree. At node 1 is the initialization. We are using LCBB here, least cost branch and bound technique. So we need to identify live nodes, E node and dead node also. Okay, first we are starting with live node is 1. So how to calculate this? If the live node is 1, node 1 calculation. Node 1 is nothing but given matrix is there na. If that matrix is a reduced matrix or not, what is the cost of that matrix we have to calculate. If the given matrix is like this, then what is the cost matrix for that reduced matrix? Okay, please calculate that reduced matrix for given cost matrix. So first write the cost matrix as it is. Okay, after that you have to get that reduced matrix. What is the given cost matrix? All of you please note down. This matrix is infinity, 20, 30, 10, 11, followed by 15, infinity, 16, 4, 2, third row, 3, 5, infinity, followed by 2, 4, third row, 19, 6, 18, infinity, 3, 16, 4, 7, 16, infinity. This is the given cost matrix as it is at node 1. Please identify what is the reduced matrix for this. How we have to reduce the matrix R value initially, how to get this? Okay, each and every row must contain at least one zero and each and every column must contain at least one zero. If the zeros are there, then automatically the given matrix is a reduced matrix. Otherwise, we have to make it as a reduced matrix. So the same procedure which we have discussed earlier, the major calculation is based on this reduced cost matrix in this branch and bound technique. First you have to cross check first row. Is it reduced mode or not? No. Then what you have to do? We have to identify the minimum value, that is 10. Okay, that's we have to identify out of the 5 values and subtract from each and every value, that is infinity, 10, 20, 0, 1. So initially we are taking the first row 10. So second row there is no 0, that's why we have to reduce with minimum value, subtract from all the possibilities, that is 13, infinity, 14, 2, 0. So we'll get 0 here and cost is updated with 2. And third row again will not contain 0. So please subtract with 2, 1, 3, infinity, 0, 2. Next fourth row is not contain 0 as of now. So minimum value is 3 in this row. Then 16, 3, 15, infinity, 0. Last row there is no 0. So minimum value is 4 in the entire row. 12, 0, 3, 12 and infinity. So all rows are reduced, but the cost is updated by each and every subtraction of the row, 10 plus 2 plus 2 plus 3 plus 4. Okay, so row wise reduced is done, but what about the column concept? So column concept, please observe one by one. After completion of the row, we have to cross check the result matrix. It contains the result is okay. First column is not contain 0, then we have to apply the minimum value, that is 1. Then the result is infinity, 12, 0, 15 and 11. So subtraction is done with 1. So second column is already contains 1 0. That's why the reducing operation is not required because it is already reduced in the column wise representation. Second one at least 1 0 is there. And the third one, please observe there is no 0 in the third column. Then take the minimum value and subtract. There is a regular procedure we need to follow, that is 12, 0. So fourth column is already contains 0. Fifth column is already contains 0. There is no need to apply any subtraction process here. So because it is already a reduced mode. So 1, 0, 2, 0, infinity. So this result value, this matrix is a reduced matrix, but the cost for that reduced matrix is okay. Row wise is this is the sum, column wise this is the sum. The total value is 14 plus 7, 21, 21 plus 4, 25. The R value is 25. The cost for initial step, okay, what is the cost for reduced matrix? Because it is the initial step only, that's why we are taking C1 is equal to 25. The cost value for node 1 is CF1 is 25. Only one value we have to calculate for each and every step. So initial step there is no previous node, That's why what is the cost value is only 25. So live node is 1. Before expanding that, we need to calculate the cost value because we are applying the least cost function. So one node is there, the least cost is the same node. That's why that node is a E node. So what is the scope for expansion of 1? What is the scope for expansion of 1? Total number of nodes are 5 na? 1, 2, 3, 4, 5. Okay, 1 is the starting point. What is the scope for next? From 1 there is a possibility for visit the remaining nodes of either 2, 3, 4, 5. So expansion of 1 in this possibility in the state space tree. Okay, the next node is either 2 or 3 or 4 or 5. That is from 1. Default starting node is 1. There is no need to represent explicitly. So from 1 to 2, okay, there is a node 2. 1 to 3 node 3, 1 to 4 node 4, 1 to 5 is node 5. So 1 to 2 is path is nothing but there is an edge from 1 to 2. Okay, there is 1 is the starting value, 1 to 2 is there is nothing but edge of 1 to 2. 1 to 3 is nothing but the edge of 1 to 3. Okay, like that 1 to 2 is nothing but okay the edge in between vertex 1 to vertex 2 representation. So the next calculation we need to calculate all these things are live nodes 2, 3, 4, 5 nodes are generated. Those nodes are live nodes. Expansion of 1 is over, that is dead node. So out of 2, 3, 4, 5, which node you have to select? Before that you have to calculate the cost value. So for node 2, what is the parent value? Is node 1. Node 3, what is the parent value? Node 1. So in this calculation, R is nothing but is the parent value. S is nothing but in the critical part is a child value. So please go to the critical part. If any S is not a leaf node, then reduced cost matrix for the S may be obtained from based on the following procedure. 4 steps are there to calculate the cost of the child node. So in this, if any child, it is a child S and parent value we are calling as R, so cost of S we want to calculate based on this procedure by applying these 4 steps in sequence. Okay, then we will get the cost value in the last step, cost of S. So how to calculate the cost of S? You will see. Okay, there is node 2 calculation. We have to observe the parent of node 2 is node 1. Means this matrix is the input for okay for all the remaining 4. This matrix reduced matrix. Okay, all of you please focus on here. Okay, this matrix is the parent matrix for this. Now node 2 is nothing but it is edge of 1 comma 2. So I value is 1, j value is 2. So the edge of 1 to 2. What you want to calculate? You want to calculate the okay cost of node 2. Before calculating the cost of node 2, please go to the procedure how to identify the calculation. First, in this result of S, change all entries of row I column j is to infinity. So what is the row I? Means first row. First row all values 5 values please change as infinity. What is the j? J is nothing but 2. Second column also please make it as infinity. There is a first step in the execution of calculation of okay reduced cost matrix S value by using the following procedure. Step 1 is change all entries in row I and column j of a matrix A to infinity. Okay, A is nothing but this value. From this value, please change the first row and second column based on the values of I and j. After that, second point, please focus and simply execute. Set A of j comma 1 to infinity. What is the j value here? As per the current execution 2. 2 comma 1 is infinity. This value is based on second step of set A of j comma 1 to infinity. Okay, next. Okay, next third point is reduce all the rows and columns in the existing matrix. But what about the remaining values? So first row, second column is fixed to infinity and A of j comma 1 and means A of 2 comma 1 infinity. How to fill the remaining values? All the remaining values, please remember all the remaining fields you have to fill with the parent vertex, parent matrix only. So what is the parent matrix? Node 1 matrix, node 1 result matrix. So node 1 result matrix is available at the end of the first calculation. So what is the remaining values? Second row remaining 3 values 11 to 0 means third row 0 infinity 0 2. Next 15 12 infinity 0 11 0 12 infinity. So all the remaining values we are filling from A. A is nothing but a parent vertex. Okay, so A is nothing but parent vertex. So after that, please cross check this is a reduced matrix or not. So all of you please observe line to line means all rows are must be reduced mode and all columns must be reduced mode. Please cross check. First row is already reduced because all are infinities, there is no issue. Second row reduced, third row is already contains 0, fourth row 0, fifth row 0. So row wise all are zeros, so there is no issue with row wise. Column wise, first column contains at least 0, all are infinity, third column 0, fourth column 0, fifth column also at least contains 1 0, 2 zeros are there, 1 0. So as per this calculation of the previous two steps, the result is in a reduced mode. So what is the cost of this reduced conversion? The cost as of now it is r equal to 0. We are not subtracting anything. The input is as it is already in reduced mode. R is equal to 0. Then we have to calculate if the reduced matrix is over C of 2, the cost of second. How to calculate the cost of second? There is a formula. What is the formula? C of S is equal to C of R plus A of ij plus R. What is the C of R? C of R. R is nothing but, as per our previous discussion, R is nothing but there is a parent value. So 2 is the current node. What is the parent value? 1. Therefore C of 1 plus A of ij. A of ij is A of 1 comma 2 plus R value. So what is the C of 1? Cost of the first value. Previously we are calculated cost of first value, na? That is 25 plus A of 1 comma 2. A is nothing but the parent matrix. What is the parent matrix? First row what is the 1 2 value here? A of 1 2. A of 1 2. A of 1 2. In the previous matrix A of 1 2. Please observe here. A of 1 2. In the parent matrix, what is A of 1 2? That is 10. So A value, A is a matrix, that is the parent result matrix. What is the parent result matrix? That is previous calculation, C of 1 calculation. What is the reduced matrix? The cost is 10 plus what is the current R value? 0. So the total value is 35. So in the state space tree, node 2 cost value is 35. Similarly, please identify the cost of 3, cost of 4, cost of 5. The calculation is very simple. Okay, that's you need to follow. At node 3, the vertex we are calling as 1 comma 3. Okay, as per the tree notation, the vertex representation is 1 comma 3. This is the I value, this is the j value. How we have to write the result? As per the procedure which we are discussed previously. Based on this, what is the procedure? If any child value, here the child is S and the parent value is, here the child is S as per the current status, parent is R. Okay, how we have to apply the child value cost function? First you have to change the entries. What are the entries are there? First row you have to make it as infinities, and third column 5 values also make it as a infinity. There is a step 1. So make all entries of row I and column j change it to infinity. What is the second step? A of j comma 1 is infinity. J is nothing but 3 comma 1 is infinity, not second row. Third row first value is infinity. After that, how to fill the remaining all values? From the parent matrix. So parent is this. This value. Okay, parent matrix is this matrix. So from this matrix, all the remaining values, the respective positions you have to fill. What is the second value? Second position. Okay, I will fill the second position. 12, infinity, 2, 0. Next, third row second value infinity, and remaining values are 0, 2, and 15 infinity, and 12. Sorry, infinity 0. Next, 11 infinity, 12. How to fill the update cost matrix is 12 infinity, 2, 0, 3, 0, 2, 15, 3, infinity 0, 11, 0, 12, infinity. Please cross check the previous one. 11, 0, 12, infinity. Next 15, 3, 15, 3, infinity 0, 0, 3, 0, 2, 0, 3, 0, 2. It is exactly correct. So all the remaining empty locations we are filled with from parent node 1 only, from this matrix only. Okay, after that please apply reduced matrix. So R value means apply the reduced for this matrix. How we have to reduce? So how we have to reduce? Reduced matrix is nothing but each and every row it contains at least 1 0 or not. Yes, it contains at least 1 0. But column wise also we have to cross check na. But all of it leaves of the first column it contains at least 1 0. No, then we have to subtract 11. So what is the result? So row wise there is no issue. Second column there is no issue. Third column, fourth column, fifth column. Only first column is the only pending. We need to subtract infinity 1, infinity 4, 1. Sorry, 0. Next infinity, infinity 3, 3, 0. Remaining columns as it is because we are not modifying because it contains at least 1 0 or all are infinities. 2, 0, infinity 12. So infinity 0, 2, 0, infinity. So all of it, please observe in this matrix it contains any row, it contains all infinities or at least 1 0 is there. So what is the cost we are using here? R value is 11. Only one subtraction we are done in node 3. So what is the total C of 3 is equal to nothing but C of R means parent value plus A of I comma j from the parent node and current R value. So C of 1 is nothing but previously we calculated na cost of the first node. Cost of the first node is 25. So the same 25 we are using plus A of 1 3 means first matrix parent matrix A of 1 comma 3. What is the A of 1 comma 3? 17. What is A of 1 comma 3? 17. Plus what is the current R value? Current node R value 11. So the total result is 25 minus 7, 25 plus 17 plus 11 is 53. Okay, this is the cost of node 3. So please update in the state space tree. Cost of node is 3 is 53. Cost of node 3 is 53. Similarly, please calculate cost of node 4. Cost of node 4 is path 1 to 4. At node 4, the cost of the path is 1 to 4 because first node is default 1. Now you are selecting 4, 1 to 4. So what is the result? Result matrix by modifying the parent matrix A with first row as per the procedure. First row is infinities and fourth column is always infinity and followed by A of j comma 1. What is the A of j comma 1? This is the I value, this is j value. J comma 1 is nothing but 4 comma 1 is infinity. So how to fill the remaining values? Remaining value is parent result matrix. What is the parent result matrix? Parent result matrix is this one, means node 1 result matrix. Node 1 result matrix, what is the result is there? That result we have to fill in this pending values. That is the matrix A. So these values you have to fill with parent matrix 12, infinity, 11 and 0. Next one 0, 3, infinity, 2. Next infinity, 3, 12, 0. Next 11, 0, 0, infinity. So these are the values from the parent node is simply copied in the respective locations from this matrix only. After that, please cross check what is the reduced matrix. If any reduced matrix changes are required, please cross check. All rows it contains at least 1 0 S. All columns it contains at least 1 0 S. So reduced matrix cost value is 0 because given matrix is already reduced. Then what is the calculation of C cap of 4? C cap of 4 is equal, sorry, C of 4 is equal C of 1. C of 4 is equal C of 1 plus A of 1 comma 4 A of ij from the parent matrix comma R. What is the C of 1? 25. A of 1 4 means from the given matrix, okay, calculation 1 comma 4. 1 comma 4 is 0 na. What is the 1 comma 4? 0 from the parent matrix, and this R value current reduced cost is also 0. So the total result is at node 5 is 25 only. So we have to update this cost matrix. This result of cost 4 is 25. Next one cost 5. So we have to update the cost 5 calculation. So node 5, first you have to write the matrix. So first row is always fixed to infinity, and it is a representation of 1 to 5 edge, that is I j. So respective column is infinity, and 5 comma 1 is also infinity. So what is about the remaining values? Remaining values you have to fill with the parent matrix. Parent matrix 1 result, node 1 result. So please fill that node 1 result. 12, infinity, 11, 2. Next 0, 3, infinity, 0. Next 15, 3, 12, infinity, followed by 11, 0, 0, 12. So this is the result matrix. From this matrix we have to cross check any reduced cost is you have to bear, or this matrix is already reduced. Please cross check row wise. This row is already reduced, okay, because all are infinities. Second row there is no 0, that's why we need to subtract 2. Third row is already reduced. Fourth row there is no 0 here, that's why we have to subtract 3. Fifth row as it is, there is no need. Then we have to change that result. So first row is as it is. Second row we have to subtract 2, means 10, infinity, 9, 0, infinity. Next one 0, 3, infinity, 0, infinity. Next 3 we have to subtract 12, 0, 9, infinity, infinity. Fifth row as it is 0, 0, 12, infinity. So all rows please observe, okay, the cost we are applying 2 plus 3, and all columns also please observe it contains at least 1 0, all are infinities. So this matrix is already reduced matrix. Cost we are identified is 5 for the node 5. Then we have to identify what is the cost of node 5 is C of 1 plus A of 1 comma 5 plus R value. So what is the C of 1 is already calculated the first node cost 25 parent node cost plus A of 1 comma 5. Please go to the matrix, okay, given matrix 1 comma 5 is 1, okay, that's we have to consider. A is nothing but there is a parent node result matrix, okay, that is 1 plus current R value is 5, that is already calculated here. So the total value is 31. So the cost of node 5 we need to update, okay, that is 35. 37. 31. Okay, so after computation this 2, 3, 4, 5, okay, we need to compute. Okay, you are following which are the live nodes 2, 3, 4, 5. Okay, we need to update the upper value here also. Initially it is infinity. Once you are calculating the cost, which is the least value 25, we are updating. Upper value is also there is a possibility to kill the node. 25 is there. There is update upper value 25. Then out of 2, 3, 4, 5, which node we have to select for the evaluation? It is not before BB or LIFO BB. It is a LCBB, least cost branch and bound technique. Which live node we are taking as a E node based on the cost value. So 2, 3, 4, 5 cost values are computed as per the previous calculations. The cost values are 35, 53, 25, 31. Out of these 4 values, which is the least cost, that node we have to select as a live node to E node. Means this node to 35, 53, 25, 31, which node we have to expand to the next step. It is not a blind technique of like as a stack or a queue directly we are using first in first out or last in first out. It is a LCBB. So this node we have to expand next. Okay, for further process due to the reason of this is a least cost node. So 4 is live node, it can be converted to E node. Next we have to evaluate 4. So once we are evaluating 4, what is the scope for evaluation for node 4 is up to now 1 to 4 is fixed. Means in this path of 1 to 4, 4 vertex as intermediate vertex we are selected. Source node is 4 and next vertex is 4. Then what is the scope from 4 is up to this part is fixed because we are expanding 4. What is the scope from 4 is remaining cities we need to visit is only 2, 3, 5. So the possibility for the next step is 2, 3, 5. The previous city is 4. So this node 6, node 7, node 8 is nothing but this node 6 is nothing but there is a edge of 4 to 2. Node 7 is nothing but there is an edge of 4 to 3. Node 8 is nothing but there is an edge of 4 to 5. What is the cost for traveling from 4 to 2? 1 to 4, 4 to 2. That's we have to calculating node 6. Node 6 is nothing but there is an edge from previous vertex to this vertex. This is the previous one is 4. The node 7 is nothing but 4 to 2. So we want to calculate this 6, 7, 8. Suppose you want to calculate node 6. What is the edge is nothing but the edge is 4, 2. How to write this edge is based on the path. Previous city is 4, current city is 2. You are selected. You are calculating the result is from 4 to 2. There is a node 6. Node 7 is nothing but 4 to 3. Node 8 is nothing but 4 to 5. There is a edge value you are calculating in node 6. So node 6 we are calculated. What is the parent node for node 6? Parent node is node 4. What is the result for node 4 in the previous calculation? What is the result for node 4? This we are considering as a parent node, a value. This node for remaining values you have to fill from this parent node only. Up to the previous calculation 2, 3, 4, we are taking node 1 is the parent value, but 6, 7, 8 the parent value is node 4. So that's why 4 to 2 is a path. Then we have to write a matrix, result matrix. Based on this, it is a I value, this is a j value. So fourth row 1, 2, 3, 4, 5. Fourth row and second column 4 means 3 values are there and this is the fifth value. So fourth row second column we have to fix it to infinities as per the procedure which we discussed at the starting. This procedure is every time we are applying the same sequence of steps based on the edge. This is I comma j edge, all the row and all the column we have to fix it to infinity. So 4 comma 2 is nothing but fourth row second values. And the second step is a of j comma 1 you have to fix it to infinity. What is the j comma 1? J is number of columns. J is 2. 2 comma 1 we are fixed to infinity. And how to fill the remaining values? So first 2 steps are only fixing the infinities in the respective locations. How to fill the remaining columns, remaining values? All the remaining values you have to fill from this parent reduced matrix. What is the parent of node 6? That is node 4. What is the result of node 4? Please observe the result of node 4 is this. This value is node 4 result. So based on this result we have to fill all these columns. So node 4, please observe this node 4 based on this matrix. Okay, all the empty locations we are filling these values only. So we have to fill these based on those values. So node 4 result we are using here, that is first row filled with infinities. Okay, and last column also filled with infinities, and remaining values are fourth column is also first row is fixed to infinity, and fourth column is fixed to infinities as per the node 4. Remaining values you have to fill here: 11, 0, next 0, third one is infinity, next 2, next 11, 0, infinity. Okay, if you have any doubt, please cross check here. The last row is 11, 0, 0, infinity, infinity. Same value we are filled here. The empty locations are 11, 0, 0. Okay, this is the result value of node 6. Node 6 is like this. Then we have to calculate the cost value. So what is the reduced value here? So all rows are already in reduced mode. First row all are infinity. Second row 1 0 is there. Third row 1 0 is there. Fourth row infinities, and fifth row 1 0 is there. Column wise, okay, all are in reduced mode. There is no need to subtract. So reduced cost is 0. So how to calculate C of 6? C of 6 is equal to C of its parent value plus A of the edge 4, 2 from its parent value plus current R value. So C of 4, what is the C of 4 value? C of 4 is 25. C of 4 is already calculated in a previous step, that is 25 plus A of 4, 2. Please go to the node 4. 4, 2 means fourth row second value, that is 3. This value A of 4, 2 is parent node respective row and respective column, that is 3. Current R value is 0. Total value is 28. So node 6 cost value is 28. Similarly, please calculate node 7. Node 7. Node 7. What is the edge for node 7? That is 4, 3. As per the state space tree, node 7 is nothing but previous vertex is 4, current vertex is 3. The path we are formed for node 7 is 4, 3. Based on that, first we have to fix the matrix. The fourth row and third column we are fixing with infinities as per the procedure. Third column, fourth row means 3 values are there and fourth value. And A of j, I comma j na, j comma 1. What is the meaning of j here? 3. 3 comma 1 fixed to infinity. First 2 steps are over. What is the third step? We have to fill all these values from node 4. What is the node 4 result? Node 4 value is all first row is infinity and fourth column is infinity in the node 4, and remaining values you have to fill 12, infinity, and last value is 0, and infinity 3, last value is 2, and fourth row is there, not there, 11, 0, infinity. Okay, this is node 7 copied from the parent node 4. So what you want to cross check now? Reduced matrix. So reduced matrix is possible. Please cross check here. At node 7 is already reduced second value, third value is not reduced, that's why you have to subtract minimum value to, fourth value is already reduced, fifth value is already reduced. Okay, then we have to consider reduce that matrix. One row we have to reduce because it is not in the reduced mode, minimum 0 is not there, that's why we have to do that process, okay, by subtracting 2. So remaining values are 1, infinity, infinity, 0, fourth row is as it is infinities, and fifth row is already in reduced mode, 0, infinity, infinity, infinity. Row wise subtraction is over. Next column wise you have to do. The column wise is nothing but first column is not in the reduced mode, 11 we have to minimum value we have to take for subtraction. Second column, third column, fourth column, fifth column already in reduced mode. Then you have to convert into the reduced cost matrix by subtracting one column infinity 1, infinity, infinity 0. Okay, and cost is updated with 11, and second values are already in reduced way. That's why we have to copy as it is. Third column all are infinities, and fourth column is also all are infinities. Is already reduced, and fifth column infinity 0, 0, infinity, infinity. So this all the rows and columns are in reduced mode. The cost is 13. Okay, this result is in reducing mode. Once you are getting the cost, then you have to calculate the value C of 7. So C of 7 is nothing but C of 4 plus C of 4 comma 3 plus R. So what is the result? C of 4 is nothing but the cost of 4 is already there, that is 25 plus C of 4 comma 3. Please go to the fourth matrix, fourth row, third value 4 comma 3 is nothing but 12. That's you have to take for the current value 12, and current reduced value is 13. So total value is 50. Okay, total value is 50. At node 7, please update in the given result, that is 50. Is it right? Similarly, node 8. Please respond for node 8. Node 8 is the path of 4 to 5. 4 to 5. This is I value, this is J value. The cost matrix is 4th row fixed and 5th column fixed, and 5 comma 1 is also fixed to 1. Remaining all values we have to copy from node 4 only. So all columns how we have to copy 1, 2, 3, 4. Okay, next 12 infinity, 11 infinity, next 0, 3 infinity, infinity, next last column 0, 0 infinity. So all of you please observe. Okay, this value is already reduced at node 8 or not? No. Then you have to calculate the reduced cost matrix. So first row is okay. Second row we have to subtract with 11. Third row is already reduced. Fourth row, fifth row is already satisfied. So the result is only second row we have to subtract. Remaining values are same as it is for the given information. So subtract 11 is nothing but 1 infinity, 0 infinity, infinity, 0, 3 all are infinities, and fourth row all are infinities, and fifth row infinity, 0, 0, infinity, infinity values. So subtraction cost 11 we are updated. So from this, observe column wise, all columns it contains either single 0 minimum or all are infinities. So column wise it is a reduced cost matrix. So minimum value is reduced cost is 11 is possible to convert into reduced cost matrix or given matrix. Then calculate the cost 8 is cost of 4 plus E of 4 comma 5 from the parent value plus R. So the result is cost of 4 is 25. E of 4 comma 5 means from node 4, 4 comma 5, fourth row fifth value, that is 0. Okay, fourth row fifth value at node 4 is 0. So 0 plus current cost is 11, that is called 36. So total value for node 8 is 36. 36. So after computing, after generating 6, 7, 8, after computing 6, 7, 8. Okay, what are the live nodes are there? Live nodes are 2, 3, 6, 7, 8. 4 is already completed now. Let's move to dead node. So 2, 3, 6, 7, 8, 5. So totally 6 nodes are available as a live nodes. Out of these 6 nodes, which node we have to select as a E node? Which node we have to expand? Now you are in the concept of LCBB. So out of 35, 53, 28, 50, 36, 31. Which is the least cost? Out of these all the cost values which are there in the live nodes, least cost is 28. That's we need to expand first. So node 6 we have to take for next expansion. In this expansion from node 1, 4 is selected in this path of node 6. followed by 2 is already selected. So from 2 there is a scope of only either 3 or 5. So as per node 6 expansion is concerned, this is a fixed path. From 1, 4 is already selected, and followed by 2 is already selected from 4 to 6. Followed by the scope is only 3, 5. So that is node number 9 and node number 10. So next path we have to expand for the calculation of node number 9 and node number 10. Okay, but please observe, please compute the same way as per our previous calculation. For node number 9, the cost is 52, and node number 10, the cost is 28. Please calculate in the same way, follow the procedure. Okay, but the cost number is 52 and 28 by using the same procedure. Once you are getting this node number 9 and node number 10, once you are getting this node number 9 and node number 10, after computing this calculation, suppose the result is 52 and 28. So 60's computation is over, that can be moved to dead state. So again, how many are in the live states? Okay, 2, 3, 5, 7, 8, 9, 10. So how many are there totally? 4 plus 3, 7 nodes are there. That is 35 cost, 53, 52, 28, 50, 36, 31. Out of these all the costs which are in the live nodes, okay, which is the least cost that can be expanded? Which is the least cost? Node number 10. Node number 10, it contains 28 is the least cost compared to all the remaining 6 nodes other than 10. Okay, that node we have to expand. What is the scope for expansion? For node 10, what is the path is already there? From starting, it is 4, followed by 2, followed by 5. So what is the scope for expansion? Only one, that is node 3. Okay, that is 11. So the path for node 11 calculation is the edge of 5, 3. The same way, 5th row and 3rd column you have to fix to infinity, and 3, 1 is also fixed to infinity. Remaining values you have to fill from node 10. Okay, then apply the reduced cost matrix application. And then you will get R value. Then you have to compute the value of C of 11 is equal to C of 10 plus C of 5, 3 plus R value. Then we will get the result is 28. Then we will get the result is, after computation of all these, we will get the 28. All of you please observe here by applying this. So from again 11 is added here. 11 is added here and is not expanded live node. Out of all these live nodes, which node it contains the least value? So 35, 53 and 52 and 28 and 50, 36, 31. These are the live nodes are available which are not expanded up to now. This is the least cost value is node 11. So again expansion of node 11 we have to do, but node 11 is nothing but 1 to 4, 4 to 2, 2 to 5, 5 to 3. Okay, this all n minus 1 vertices are visited. Okay, as per n is equal to 5. So there is no scope for expansion. That's why we have to declare it is a answer node. So it is a live node. Okay, which contains the least cost, and we have to specify it is an answer node. Once it is an answer node, is nothing but what is the cost of this path? The cost of this path is, what is the cost of this answer node is 28 to travel to all the visiting of all the cities at most exactly once. Okay, but what is the path? Path is also important in the representation. For node 11, from the root node to node 11, what is the sequence of vertices we are selected? That path is like this. We have to travel, okay, from root node to this. So default value is 1. So what is the first vertex? 4. What is the second vertex? 2. What is the third vertex? 5. What is the next vertex? 3. End vertex is also fixed. So based on this tree, we are generating n minus 1 vertices. First vertex and last vertex is always fixed as per our first discussion. Is always fixed to 1. Out of all the permutations, this permutation gives the optimal path. Okay, optimal path with cost of 28. Okay, this is the result we have to announce at the end of the solution. Okay, it is the least cost branch and bound representation for traveling salesperson problem. What is our aim? To identify the what is the minimum cost and identify the what is the path to travel all the cities or all the nodes exactly once without any repetition to identify the minimum cost. So the path is already declared 1, 4, 2, 5, 3. followed by 1. So 4253 is only we are getting from the tree. 1 is already fixed. So this is the result. I hope everyone is clear for LCBB. In the same way, we have to expand the same problem with FIFO-BB and LIFO-BB also, but it produces more number of nodes in the calculation. Because that's why out of those three, LIFO-BB and FIFO-BB and LCBB, the best technique for with minimum number of nodes in the state space tree to identify the answer node is LCBB. The same logic we have to apply for FIFO-BB and LIFO-BB with the same calculation. FIFO-BB is nothing but first we have to expand 2. First you have to expand 2 with all the possibilities. Okay, next expand 3, next expand 4, expand 5, next expand like as a BFS. Okay, LIFO-BB like as a D search. Finally, we get the answer node like this type of path, but the searching space is more compared to the LCBB. So please apply any one technique of either FIFO-BB and LIFO-BB for traveling salesperson problem, or the same problem please consider and apply this procedure. This procedure is very important. The same procedure we are applying repeatedly, okay, for each and every node. Okay, I hope this you got this calculation. Okay, then it's more than enough for identify the solution of traveling salesperson problem for LCBB. FIFO-BB and LIFO-BB is not there in the syllabus, but we have to practice for getting the meaning of how we have to track with LCBB and FIFO-BB. Anyone have any doubt? Please ask. 1 more minute is there. Please type in the chat box. This concept is clear. Then please type no doubts or yes, it's clear. Like that. If you have any doubt, please ask. All clear? Please get through. 1481. Thank you. Any more? Please respond in the chat box. Dinesh, thank you. Harshavardhan, thank you. Abhijit, thank you for your listening and got the knowledge on traveling salesperson problem. Sucharit, Satvik, thank you. Out of this huge number of participation, only few members are responded. We got the meaning of traveling salesperson problem. What about the remaining members? The choice is yours. Please type in the chat box about your feedback on the current topic. It's very much useful to you, especially. Okay, if you got the meaning, that is good. Otherwise, we assumed that we delivered in all the aspects and it's reached to the students. Without your valuable feedback, we don't know what is the status of the current topic discussion. Okay, if you are clear, thank you. Thank you, Subbarao Garu. Thank you, one and all. So this is the last topic in CO3. So from next session onwards, we'll start with CO4. Okay. Now, any doubts we will clarify in the next session when the sessions are free after completion of CO4. Thank you. Thank you, Subbarao Garu. Please end the session. Subbarao sir. Sharp 310. Thank you, sir.